Hey everybody, today I'm going to talk a little bit about the Freda Sandstone. This will be part of the Freda files. As many of you know, I am actively trying to pull zircons from this formation, and I am trying to establish members within the formation. This has been an ongoing long project. Originally, I redefined the stratigraphy of what is now the Jacobsville group. It used to be the Jacobsville Sandstone. I've gone over this before, and then I did the Copper Harbor Conglomerate. And Copper Harbor Conglomerate is the bottom formation of the Oronto group. Above that is the Nonesuch. I'm not touching that. It's too complicated. The Freda is the top of the Oronto group, which underlies the Jacobsville, which we know the Jacobsville is now Neo-Proterozoic in age. This stuff is very late Mesoproterozoic. We suspect it could cross the Neo-Proterozoic line a bit. But I don't think so. That's why I'm pulling detrital zircons. It is sedimentary. It is moderately to well indurated. It is primarily a sandstone. Most people do call it the formation. Now, I've gone over this before in lithostratigraphy. A dominant lithology can be used in lieu of formation. It's the only lithostratigraphic unit this happens at. It's also one of those long time standing things, but it's falling away. I mean, when I write these papers, it's going to say Freda Formation, not Freda Sandstone in the title. All right, so it's sedimentary, mostly sand. So the basic question was, how do I know where to go? And that is actually not a very simple question. It is a very complicated one. Now, the Freda Sandstone or formation is exposed from not that far from my cabin, way up on the Keweenaw, all the way down through the UP, following Lake Superior, through the northern tip of Wisconsin. The Freda Formation takes up a big area. It is exposed not that far from my cabin. That's the base of it, with the contact of the Nonesuch. So at least I have one basal contact exposed. And it goes all the way through the UP, through northern Wisconsin, crops out at the Wisconsin-Minnesota border. And pretty much from there, it's only known from the subsurface. There is a great core on the eastern side of the Upper Peninsula in Auger County that I've used for the Jacobsville paper that goes through the Jacobsville. It goes through the Cambrian, the Jacobsville, the Neo-Proterozoic, and the Mesoproterozoic Oronto groups, all the way down to the volcanics. It's a beautiful core. East of the Keweenaw, that's the only thing we really got. So we know it's there. And I've already picked out where that upper contact is. The upper contact, as far as I'm aware, between the Freda and the Jacobsville, there is an unconformity in that core. Other than that, I don't know if the contact is exposed anywhere else. I don't see it on any of the geologic maps which I used. The thing with doing something like this on a formation this large, it takes up this much area, and it's not continuously exposed the whole way. It takes up too much area. There's a lot of glacial stuff, but it's really well exposed, and especially for being as weak of a unit as it is compared to the underlying volcanics. The only place where it could possibly be exposed in outcrop from what I have gained from the geologic maps is along Lake Superior in Wisconsin. And we have a boat for that, but that might take a little bit. When you're trying to redefine a geologic unit, you need to start somewhere. And I am using this thesis as my starting point. It's very detailed. There have been other theses on the Freda, like in 1958, that along the Montreal River, which I've looked at. The Upper Peninsula of Michigan has two Montreal rivers. This is the one that separates the UP from Wisconsin. It's an okay one. It's not very long, but the problem with this is this formation has gone through a lot of weird names. Like originally it was referred to as the Eastern Sandstone along with the Jacobsville Formation. And there had been arguments once it got divided from there, it actually, and Bayfield Group as well, but Bayfield Group's no longer a legitimate unit. I'm oversimplifying this, but this is basically how it went. You had eventually that became the Jacobsville and Freda separated out in the early 20th century. There's a beautiful paper and map. It was before we were aware of like the Keweenaw Fault, the Owen Fault. well, the Keweenaw Fault stretching out as far as it does, I should say. We were aware of it a long, long time ago. But the Owen Fault, the Douglas Fault, those faults, it was thought that there were a lot of anticlines and synclines, especially in northern Wisconsin, which turned out not to be true. And originally there were two other units. We had these two formations somewhere within there. Originally the Amnicon and Aline were placed between the Freda and the Bayfield, which is now the Jacobsville group. So, but according to that, even in that paper, the Aline is described as being very Oriental-like, which was the original basal formation of the Bayfield group, which means these two could possibly be switched. Subsequent mid-20th century heavy mineral analysis kind of confirmed this. So really what we have is something like this. You have three main formations. The Orienta, I'm not going to write them all out, would be the basal, which would include the Aline. The Amnicon is possibly the top of the Freda. And this is just in Wisconsin. This doesn't go past up onto the Keweenaw into the UP, and I'll explain why in a second. So you can see this is getting messy, and don't worry about what I wrote if you can't understand it. The point is, it's not as simple as everyone originally played it out to be. And that mess of stratigraphy, like I said, there was heavy mineral analysis done, which led to the Amnicon being placed in the top of the Freda, and the Aline in with the Orienta, which is the basal formation in Wisconsin of now the Jacobsville group. That's what the heavy mineral analysis led us to. However, I am pulling detrital zircons to confirm that or refute that. What we have in between, where we have Minnesota, Wisconsin, and the UP of Michigan, this is not a very good. You basically have Lake Superior in here. This is the Montreal River I'm talking about. The UP comes up here. Here's the Keweenaw. The Freda comes down. In this area right here, we have what's called the Porcupine Mountains, which the Copper Harbor conglomerate, the basal Oronto group formation, is exposed there. And so is the Nonesuch in the Freda near White Pipe Mines and along the lakeshore. But these, from what I've seen thus far, the Porcupine Mountains seem to form a physical boundary. They were actually a volcano when the Mid-Continental Rift was trying to rift. This was a volcano that formed along this rift. The Freda up the east side here and up on the Keweenaw is looking a lot different than the Freda on this side. What I am leaning to right now is the Freda, and this may change. I did develop a conceptual model when I first started doing this, and that's important. The conceptual model is going to change, but that's developing something like that guides you, helps you out. It's almost strictly based off that 1960s thesis with some other things thrown in there. So on this side, the Freda doesn't seem readily divisible into subunits. Now we have a couple little things in here that we don't have on this side, and hopefully detrital zircons will answer that. It's very fine grained over here. There's no really coarse parts. Over here, it does seem divisible. And remember, this stuff is usually steeply dipping. Not always, but here, especially on the Montreal River, it's almost vertical. I've done a video on that. This side, it does seem to be divisible into three members thus far. And others have mentioned this. A basal coarse, a middle, I'm not going to write middle, a middle fine, and a top medium to coarse. Okay, so that seems to be the thing, and this part has what appears to be tongues and lenses of actual conglomerate in it, alluvial type deposits, kind of what you would see within the underlying Copper Harbor, but just not as thick and not as widespread. I mean, the basal Copper Harbor is almost, when it's not a sandstone, is almost all alluvial conglomerates. Up here, when I say fine, I mean fine sandstone, siltstones, that kind of thing. And up here, I mean more medium to coarse sandstone before it gets into contact with the overlying, because there's an unconformity, at least I think in Wisconsin, the Jacobsville. Like I said, there's an unconformity in the St. Amour core, but I don't know. I have to find the contact over here if I can to see if it's there. And that upper contact is going to pose a problem if I can't find it in outcrop, because if I do define the top of a member, say this is a legitimate member, it's going to make describing it difficult because it doesn't seem to be in core elsewhere. So I don't know. Maybe I'll be able to figure it out. Maybe the old Amnicon or Eline, I'm going to look at some of those outcrops, will help me decipher this. And I would just be redefining the Freda where it's an outcrop. There's a structure that I'm going to use as a boundary, because as the Mid-Continent Rift goes from Lake Superior and goes under in Wisconsin down through to Minnesota to Iowa, there's no surface exposures and the sandstones change names. The stratigraphy kind of breaks down. I'm not going to address that. But I can use well logs where there aren't cores. But I've already done that for the Montreal River. Pulled the well logs around it, and like this is for the UP side. Gives me, as you can see, the descriptions aren't the best. I mean, these are generic driller descriptions, and Wisconsin is in here as well. So here's the river. Some Wisconsin sides. See, same generic descriptions. This is common. And there are even some people I can tell we're not local drillers, and I think I'm able to translate drillerese, because it happens. Some places there is conglomerate, which actually does help, because along the Montreal River it's about 100 feet or 30 meters of it exposed, and so it seems to go into Wisconsin and thicken. Let's see if I can find it here. A couple of them, they have granite where they hit bedrock. There is no granite there. There's not even any granite underlying the Oronto group. That is a driller who doesn't know the area very well coming in. And what happens is when they drill down, they usually, to put these wells in, they're not taking cores. They're blind drilling down. You go down, here's your surface, here's your drilling tool. You go down, and as you go down deeper and deeper, comes up are the cuttings, and they get, because this thing actually has, you know, teeth on it, and they pile up here, and these are called auger cuttings. So they're little bits of rock, usually like this, depending on what you're going into, usually about that size. So somebody who's inexperienced looking at an arcosic or lithic sandstone might not know that's what they're looking at, and they might not be thinking that, well, this is really easy to drill through. Maybe I shouldn't call it a granite, but whatever. That's how drillers are, and I'm not going to pass judgment on that. So when I redefined the Copper Harbor Formation, the Basal Oronto Group Formation, and the Jacobsville Group, I did not take detrital zircons. I did not need to. There was enough outcrop of the detrital zircons had already been pulled from the Jacobsville, something like 2,500 of them. I didn't need to do that. The Copper Harbor conglomerate has dated lava flows, solid ones, within it. So that I didn't need detrital zircons from that. But I do from the Freda. And like I said, it's to answer that Amnicon Eline issue for sure. I've already talked about in another previous Freda video, background, how you start this, but I'm just going to touch on it quick. First, before you do anything, you need to consult the available literature. Somebody on a formation this size is going to have done some work on it already, even if it's vagueness. But what you need to do is consult any sort of theses or dissertations or professional papers, if there are any. I'm just going to write professional publications, abbreviated, that, and maps. And there are a lot of maps up along the side of Lake Superior. The trouble is there are no 1 to 2400 or quadrangle, 7.5 minute quadrangle scale, except up on the Keweenaw, and they're White and others did not separate the Nonsuch from the Freda. They mapped them together. So I've got to rely on the more smaller scale maps, the more zoomed out maps. So that's where you start, and you use those to develop a conceptual model, which I guarantee you is going to change. Then what you do is you plan your field work to look at outcrops, to grab samples for analysis like I've done here, are my lab samples. I keep all this stuff. My detrital zircons are in buckets. They are closed with the lid on, inside sandbags, labeled for analysis. And they're bigger samples. You need a lot more when doing this. So you do your field work. That's very important. You plan your field work before you do it. Sometimes you might get lucky. You might be driving around, you look at a ravine and you see an outcrop and it answers a question. And there's a lot of blank areas in the Freda. Like I said, it is glaciated, especially on the Montreal River. There's almost a mile or a kilometer and a half where it's not exposed at all. So we have like the very basal part and the middle and upper part, or upper middle and bottom upper part exposed, but we don't have that lower and middle exposed. But that's what I'm using these well logs for, to try to fill in those blanks a little bit. Obviously I can't use those to define any units with generic descriptions like sandstone and conglomerate, but it helps fill in blanks. So you do your field work. Oh, and well logs would be up here as well. Once you do your field work and you go out there, you might have to come back here because you need to refine what you've done, and you may go back then here. These two may happen, go for a while. If you have, once you complete this, my advice, you don't have to do it this way, this is my advice, then you look at actual rock cores. And that repository was in Marquette. I don't know if it's still there. They were talking about moving it a couple years ago. I need to look at the St. Amour core again. I'm only going to look at a handful of cores. I'm not going to pull any detritals from there. I am pulling those strictly from outcrop, as far as that's the plan right now. So you look at your rock cores, and in between here, you're looking at your lab samples, classifying them, and I'm already learning from what I've actually looked at, because I have tools that were not around even 60 years ago, let alone some of these 120 years ago. As I'm starting to find what they were calling siltstones are actually wackies. But, I've talked about that before. So you look at your lab samples here, your rock cores. At any point here between, field and rock cores, if you have the funds and the means to do so, and you're doing detrital zircons like I am, you can send them out. I'm going to send these out last. Okay. And like I said, your conceptual model that you developed here, you keep changing it as you go through, as need be, to reflect what's actually physically in the ground. And you want to record your GPS locations, your outcrops, everything, take pictures, all that stuff, so somebody else can go out there and verify it in the future, or find something, because it may affect the work they are doing in the future. And it could be 10 years from now, it could be 100 years from now. And I am using this here, 1885. Why? Because I don't know what it is. It seems like from the late 19th to mid 20th century, people would go out to outcrops, take pictures, write detail. I've been to this wall. This is Jacobsville. It's pretty cool. It's on private property now, but it wasn't in the 19th century. They draw detailed stuff like this from their notes in these books, and they would give accurate locations the best they could. It was township and range then. Sorry, no GPS in 1885. But I know where I know where a lot of these are, and some are gone or covered or whatever on private property. But this type of documentation seems to have been lost over the years. I try to do it, and it's very important to keep doing it. Sorry, that was a side rant. So after you have done your field work, which may require some back and forth, moved your conceptual model along the way, studied your lab samples, your rock cores, documenting this whole thing the best you can, and some of you have already seen it. I don't have it with me right now, but I have an actual lab book that I use when I look at these samples. You can decide on what you want to publish. Now, you may have a picture of what you want to publish in your mind around here, and actually that has occurred with me. You need to keep all your notes, and all my field books, all these samples, I will leave to somebody. I'll probably leave my field notes to Illinois State University, the actual books and the scans and stuff like that, so somebody else can use them in the future. I don't know what I'm going to do with these samples. My guess is when I die, they'll probably just go away. Somebody will just throw them out. I don't want that to happen, but I don't know what else to do. So, but hopefully that won't be for another 30 years, so 30, 40 years, so I have time to think about it. But anyway, what do you want to publish? Well, when I did the Jacobsville and I did the Copper Harbor, it was one paper for each. Lithostratigraphic reclassification, both units. This time I think there's going to be more papers, because my detrital zircons are going to be a paper in and of themselves. Now, I've said this before, you can't get an age of the sandstone from your detrital zircons. You cannot be older than your youngest zircon. You can only give you a maximum age, but you can get other data from the detrital site source area. And I have this distinct feeling in the Porcupine Mountains that I talked about before, that west of that, there is a distinct different source area than there is from the east. And just by what I'm seeing in outcrop leads me to think that. The detritals will confirm that. I have the feeling that the stuff west of, and there might even be 2 or 3 different source areas to the west, is mostly from, well, obviously the south, but might be a little further away, like real far away. Like we might be talking basement rock, possibly from, Iowa, something like that. On the east or east of the Porcupines, I don't think it's that way. I think it's more local, even though it's finer grained. The lithics I see in it look more like local lithics. I think the stuff to the east was just recycled more in the Freda. So, but that may change. That's just me looking at it, and that's a hypothesis. I formed a hypothesis that I'm going to test. Remember, assumptions are fine in science as long as they make predictions, and I made 2 predictions just now, when I'll find west and east in the form of hypotheses. And if those predictions, those are pretty accurate, detailed predictions. They're not, well, to the west I'll find sand, to the east I'll find sand. It's not general stuff like that. So I will use those hypotheses, and I may be totally wrong. It happens. Well, I move on. I'm wrong a lot. So the papers I think are going to come out of this, as I'm thinking, at least one detrital zircon paper, which I would like to write first. I'll actually probably write the stratigraphy ones before that and just keep them on the burner in case the detritals might affect that, but it shouldn't affect that. All right. So the detrital zircon one will probably be the first one actually published. The second one will probably be on the overall structural interpretations of the Freda in outcrop, and the third will probably be lithostratigraphic reclassification. This is going to be the most complex of the formations that I do. It is the most understudied. There's really nothing in it that has any economic value. It's a nice aquifer, but that's about it. Like I said, there is an intrusion in this that has been dated up on the Keweenaw, in the bare stock rhyolite or felsic intrusion, whatever people call it. It's a bare stock, but it has a margin of error, I believe, of plus or minus 32 million years. So it's a 64 million year window of error, and that's not good enough to lock this thing down. Hopefully the detritals will help narrow that as well. So basically this is the process that I'm using to collect data on the Freda. Usually what somebody's going to do for a thesis or something like that, or a mapping project, isn't going to be this detailed. Like I said, the Freda is a huge area. I'm trying to do a lot here. This will probably end up being my primary life's work. So this is probably what I'll be remembered for, at least from a geologic standpoint. I mean, your personal opinion of me is what it is, I guess. But anyway, now I was talking about publications and background research, and you should only be you looking at the actual published works when you do stuff like this, and I have a lot of it, you don't want to, I mean, there are some really good amateurs out there, but you really shouldn't rely on their stuff. I hate to say that because I've run into too many problems with that, misidentifications, things like that. I'm not dogging amateurs. Some of them do really good work, but here are my color-coded publications that I use. They are either originals in some cases, like this. This is Greenland. Some are scans, printouts of those scans. Others are just from online. There's a lot of online availability right now. Yeah, the Greenland stuff. But these are very helpful right here in what I'm doing. There are others, and these are very old publications. They're over 100 years old already, and they have beautiful outcrops in them, like this one does. So, yeah, I just thought I'd show you some of my publications, and you guys have seen this. That's the granite one. This is about the Sudbury structure. It's still the most definitive collection of papers. It's a collection of papers. It's not a book. And my color-coded stuff. And real quick before I go, a nice piece of copper. I'd forgotten where this was, and I found it. So it's about 1.3 kilograms, which is just shy of 3 pounds. So it's pretty much pure copper. You can see the weathering, which started to turn green. The oxidation, I should say, on it. And I gotta put it in a better place so it doesn't keep oxidizing, because that's some beautiful copper on that. And as you guys know, it's not my only copper piece. I think that's all I'm going to talk about for now. So if you have any questions or comments, please leave them below, and I hope you learned something.